All right, so this is Transformations Lesson 5, and it's all about stretches and working through how stretches work. So um, we're going to start off with just dealing with this graph of y equals root 4 minus x squared. This is actually a half of a circle. Circles, it turns out, are x squared plus y squared equals r squared, but we'll get to that a little bit later. So what we're going to do is we're going to see how this works with 3f at x. Again, they continue asking us to write the equation that represents this. There's going to be 3 outside 4 minus x squared, but I'm going to suggest that we just do this. y2 equals 3 times y1, and just leverage our calculator's ability to do function notation for us. So I'm going to go through these here. Feel free to pause this and just do these experiments on your own, but I'm just going to kind of rock these through. 3y1 at x, graph it. Now, it looks like it got moved upwards as well. It turns out that it didn't. My calculators can't draw vertical lines very well. So if I go to zoom decimal, which is a slightly nicer zoom, you get a much better vision of this. You can see it does go all the way down to the axis. You just can't see the top of it, which would be at 6. So in general, what this does is it does a vertical stretch. It takes all the y coordinates and multiplies them by 3. So I prefer actually seeing this like this, y over 3 equals f at x. So I've replaced y with y over 3. And what that does is it stretches it. And it stretches vertically. The x-intercepts are the same. They're still at -2, 0, and 0, positive 2. The y-intercept has changed. It's gotten multiplied. So the y-intercept went from 2 and is now 6, 0. I could draw that like this. That point maps to this point. Same thing here, except now I'm going to do 1/2 f at x. So I'm just going to go back into my calculator, and down here just go insert bracket 1/2. I could have also typed 1.5. Delete that, graph it, and we can now see it's gotten shorter instead. Kind of a compression. We talk about compression as just being fractional stretches. So it's always still a stretch, just fractionally. So this is vertical stretch by 1/2. The x-intercepts are still -2, 0, and 0, 2. Y-intercept, though, is now 1 instead of 2. So this is a vertical stretch about the x-axis by a factor of a. Now, again, it's actually better to think about it like that. The replacement helps you understand what's going on. In this case, I'm putting an f at 4x. Again, I would just do y2 equals y1 at 4x. To show what this would be graphically or algebraically, it should be 4 minus 4x all squared. Now, if I'm putting that into my calculator here, just to see what it's going to do, clear, 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 at 4x, close my bracket, graph. There's my original, and there it is. What's actually happened is it's gotten smaller by a factor of 4 horizontally. Now, that's kind of tricky, but if we think about it in the same form that the other one was, I'm replacing x with 4x, or I could go x is being replaced by x over 1/4. Those are identical to each other, and now you can see this is my stretch. So it's stretched by a factor of 1/4. So horizontal stretch, x-intercepts became -0.5, 0. They divided by 4, and positive 0.5, 0. The y-intercept stayed the same at 0, 2. I keep trying to put the y coordinate first when I'm doing the y-intercepts, apparently. Down to here, if we go 1/3 of x, that's the same as, well, let's just write it like this. To put another open bracket here. 1/3 times x, close my bracket. This is going to actually stretch out wider. So instead of 2, it's now going to go to 6. Just like that. So this is a horizontal stretch. And the x-intercepts got wider, -6, 0, and 6, 0. They were multiplied by 3. And the y-intercept of the graph stayed the same, 0, 2. Okay, did it right that time. And we call this vertical stretch. No, sorry, horizontal stretch. About the y-axis. And again, I prefer seeing it like this. X has been replaced by x over c. And then we can talk about this c is my stretch factor instead of a factor of 1 over b. So I'm just going to do these things instead of actually writing them out. You know what? I'll go through the whole thing at least once. We're going to put in -3 here, x cubed, plus 6x squared as this distributes in, plus 15x minus 18 as we distribute that into everything. But what's going to happen is that it's going to actually go negative. It's going to be from here down to -24, back up to here, to +12. Like that. And so this is a vertical reflection and stretch by 3. X-intercept stayed the same, y-intercept multiplied by -3. So vertical stretch about the x-axis and a reflection in the x-axis. Here, if b is negative, this is going to be a negative horizontal reflection, or reflection in the y-axis as well. So instead of 1, this is going to be -3. Instead of 3, this is going to be -9. Instead of -2, this is going to be +6. So it's going to look something a little bit. Let's see if I can draw that actually correctly to start. This one's about 2, so it's going to be about -6 is be where the minimum is. And the minimum value itself is still the same. So something like that. Anywho. Yeah, I don't really want to do this whole thing. We can. The reason they're asking us to is just to be able to type it into the graphing calculator. But we can just do that with y2 equals y1 at -1/3 of x and go with it. So here it's a horizontal reflection and horizontal stretch by a factor of 3. The x-intercepts got multiplied by -3. And the y-intercepts stayed the same. So we call this as a horizontal stretch about the y-axis and a reflection in the y-axis. So just if the thing's negative, it reflects as well. Filling this in, this is going to be stretched vertically by a factor of a about the x-axis. If it's bigger than 1, it's still stretched vertically a y-axis. If it's less than 0, it's reflected vertically, or a reflection in the y-axis, then goes through the rest of those pieces. If B is between 0 and 1, it's stretched horizontally by a factor of 1 over B. Now, if B is fractional, that's going to make it a bigger thing. So, like 1/2 becomes 2. You always have to remember it's just always the reciprocal. But if B is small, it's going to get bigger instead of the other way around. And it's reflected about the y-axis here. Now that we're dealing with horizontals, this is still stretched horizontally by a factor of 1 over B about the y-axis. And if B is negative, it still does the same thing. It's just also reflected with the stretch. Here they fill in all that same stuff. They talk about our replacements. And there's the notes. So now what we're actually going to do is just write these things out. So if I want to stretch by a factor of 6 about the y-axis, it's just going to be y equals f at x over 6, or 1/6 times x. Vertical stretch by a fifth is going to be the outside. So it's going to be 1/5 f at x. A reflection in the x-axis and a vertical stretch, both by 3. So if I'm going to stretch vertically and reflect vertically, it's going to be y equals -3 f at x. Horizontal stretch by a factor of 1/2. That's going to be the b value of 2. So it's going to be f at 2x, and vertical stretch 1/4 out here. Again, personally, I would prefer to write this as y over 1/4 equals f at x over 1/2. Then it's just whatever your factor is just goes in the denominator. I will accept all those on my things. This is going to be vertical stretch by a factor of 1/3. We could see that too if we moved it over to this. What happens when we make this? If x gets replaced by 4x, it gets stretched horizontally by a factor of 1/4. This is going to be vertical stretch factor 3, and this is going to be vertical stretch factor 1/6, and horizontal stretch factor 3. So if I want to draw this, f at -2x. So it's going to first flip horizontally, and then it's also going to be a half of its former glory. Now again, I've showed this a couple times here, I think, in these videos, but I'm just going to literally write this out here. This is the original, so I put an O there. This is the new graph, so I put an N there. And now I can go x old equals -2xn. That doesn't really give me all that useful a thing. What I really want to know is what is the guidelines to get to the new value. So your xn is going to be equal to xo over 2. The 2 times is probably a little, you can write like that, -2 like that. So it's just going to be take the old point and divide it by -2. So this old point is at -6. -6 over -2 is 3. This old point's -4, -2, or a +2. 0 stays 0. +4 is going to move to -2. +5 is going to move to -2.5. And then +6 is going to move to -3. So that's what that'll look like. All right, so that's that assignment there. Hopefully that makes sense. Come back at me with any questions.